Problems in 3 dimensions, example 3. From the top of a vertical cliff 100 meters high, a boat A lies in the direction south 30 degrees east and boat B lies due east. The angle of elevation of the top of the cliff from boat A is 20 degrees and the angle of elevation from boat B is 15 degrees. Calculate how far the boats are apart and give your answer correct to the nearest meter. Let's break this problem down into simpler triangles that we can solve. Firstly, if we look at this triangle CDB, it's a right angle triangle. We know 2 bits of information already, that CD is 100 meters and it has an angle of 15 degrees. If we label this right angle triangle, we can see that compared to the 15 degrees, the 100 meters is opposite, and this side, X we'll call it, is the adjacent. So tan of 15 degrees is opposite over adjacent, which is 100 over X. Rearranging this formula, we can see that X is equal to 100 divided by tan 15 degrees. So we'll use the calculator to evaluate this. When we do, we see that X is 373.2 meters approximately. Now, if we consider this pink triangle here, this is also a right angle triangle because the cliff face is vertical with the sea. So we have a cliff face of 100 meters and we have an angle of 20 degrees that is opposite to this 100 meters. I'm interested in the edge AC because this is part of the triangle that's on the sea floor. Let's call AC, let's call it Y. So we'll call this side Y. So I want to evaluate this. Again, labeling the sides, I see that the 100 is opposite to the 20 degrees and Y is adjacent to the 20 degrees. So again, I'm going to use tan to evaluate this. The tan of 20 degrees is opposite over adjacent, which is 100 over Y. So rearranging the formula, I see that Y is equal to 100 divided by tan 20 degrees. When I put this into the calculator, we see that Y is equal to 274.7 meters to 1 decimal place. Now we're getting close to solving the problem at this stage. If we consider this triangle that's on the seafloor, ABC, we can see or work out that it has an angle of 60 degrees because the 30 plus 60 makes the 90 degrees. It has one side of 274.7 meters that we've worked out. It has a side of 373.2 meters that we've evaluated. And it has this side D. It's a non-right angle triangle. Therefore, I have a choice of using maybe the sine rule or the cosine rule. I can see that the information here involves 3 different sides, so it's the cosine rule that I'm going to use. I have one angle and 3 sides that I'm interested in. So using the cosine rule, D we can see is opposite this angle 60. So I can see that D is equal to the square root of b squared plus c squared minus 2bc cos A. In that case, it's 274.7 squared plus the other side, 373.2 squared, minus 2 times the 373.2 multiplied by the 274.7 multiplied by the cosine of the angle between those 2 sides. That's the cosine of 60 degrees. And I just sub this directly into the calculator. And when I do, I see it evaluates to be 335 meters correct to the nearest meter. That's what we were asked for in this case. That's the solution.